Hey guys, welcome back to my YouTube channels. My name is Steve, and in this video I'm going to share my learning note for learning protocol buffers or Protobuf. So what is protocol buffers? Protocol buffers are a language neutral, platform neutral, extensible mechanism for serializing structured data. Serializing structured data, yes. So if you're already familiar with XML or JSON, they also do serializing, and this protocol buffers is created by Google. They created it by 2001 and made it open source at 2008. They said this is platform agnostic and also programming language agnostic. It means that you can use Protobuf, sharing the Protobuf cross-platform. Let's say from Linux to Android. And you can serialize and deserialize Protobuf in different languages that is supported by Protobuf, of course, right? And at the time of recording, September 2022, these are the supported programming language: C++, Dart, Go, Java, and so forth. And I'm going to show you a very simple demo later on, which is using Go because I'm writing in Go. All right. So next, I'm going to show you an overview how Protobuf is actually works. In this section, I'm going to share with you an overview of Protobuf. So let's say I have two different services. One is in Go and the other service is in Python. So we have to create the proto file that define the schema that we are going to use for all the languages that we are going to use. So we create proto files here. So it contains a schema of the data that we want to share. After we define, and then we use a compiler to compile two different languages, for example in Go and Python. And then after that, using these codes to interact with the data inside the schema. For example, in Go, I want to write data, so I use the compile code to write the data, and then after that, serialize the data using a library, and the output will be a binary. And this binary data that we will send over the network, let's say we send it to Python once, and then once it receive, it will be deserialized by a library, and then using the compiled code, the Python server will read the data from it. So the beauty of Protobuf is we only need to define one proto file, one schema, and then we can use for different programming languages. So that's an overview of Protobuf. Okay, so in this section, let's take a look at proto files that we want to use for our demo. So if you want to follow with me, you can access the learning materials in my repository. The repository name is learning-protobuf. And then let's go to payment/v1 directory. So payment is the package name or the service name, and v1 is the version of the payment at the moment. So I find this kind of like the best practice of how we should put our proto based on version and based on the service or package. Please correct me if I'm wrong, because I never done this before. Right? If you have any idea of best practice of how we should put proto files, please let me know in the comment sections. So let's take a look inside the payment.proto. Right, why this is so slow? Alright, never mind. If that's so slow, then I can show you the one in my laptop. Payment v1 payment proto. Cool. So this is our payment proto. So if you notice, the first syntax is the way we define the version of proto that we want to use, and at the time of video is recording, the latest version is proto 3. After that, we give a name for our protobuf, the package name, which is payment dot the current version at the moment. And then after that, this is an optional configuration, go package. So I found out that this need to be put, otherwise I could not compile this proto to Go source code. Right? Please correct me if I'm wrong. But Go package is basically define the import path of the package for the Go, which will contain all the generated code for these files. And then this payment PB is the package name that will be used in the Go source code. Right? But the main important things actually is this message, right? So message is basically like a struct in Go language, right? This is the data structures, and then this is the name of the message order. And after that, I have 3 fields. So in Protobuf, fields contain 3 parts. The first one is the data type. The second one is the field names, and the latest one, or the last one, is a unique number, which is basically to identify these fields inside the binary. So when we deserialize it, it will know which data belongs to which fields, right? So it used this unique number for tagging, right? And then Protobuf also support enum. For this example, I have payment provider enum, contain list of payments option that supported, and I use this as data type for my payment underscore provider field name, right? So this is the protobuf file that we are going to use. There are so much more of writing protobuf. Please take a look into the documentations. It's already there for you, right? Okay, so in this section, we are going to compile the proto files that we have defined before into Go source code. And there are prerequisites to compile it. The first one is to install Proto-C. Let me open the link. So you need to install Proto-C, generating your classes, right? You go to this download package and then you install the Proto-C. And then after that, you have also to install Go plugin for Proto-C, right? Just run these commands and then it will install for you the plugin. Basically that's it. But in my demo, I'm going to use a tools called buff instead. Let me open this. So buff is basically a CLI tools that we can use to work with protocol buffers. It's quite popular. It has 5.4k stars. So it has bunch of features. I haven't tried all of them, but I'll show you how buff can ease our development in terms of generating codes, and also we'll show you how we can use the linter to detect uh, invalid proto files that we write. All right. Okay, in this section, I'm going to show you how we can generate proto files using buff. So if you are first time using buff in your root directory, you should run this command buff mod init, right? What it will do for you is generating this YAML configurations, right? So technically, you can modify this configuration if you want to use another feature or options that provided by buff. But for this demo, I'm not going to touch it yet, right? So I will uh, leave it default like this. Cool. The next thing is that you want to create a file called buff.gen.yaml. This is a configuration file that we will use to generate the protobuf into the source code. So here I define in the plugin sections that I'm going to generate a Go source code, right? And then the output should be in the directory name gen/go. And then I can also specify an optional flags for Protoc, right? Because in the background, this will run Protoc, right? So here I specify paths is source relative options, which tell Protoc to use relative paths to generate the output. If you want to add more languages, you just need to add more items. For example, in Python or in C++ and so on and so forth, right? So here I already have the output in the gen directory, but I will remove it. Cool. Let's take a look. It's gone. Let's generate, right? Buff generate. Cool. Let's take a look. Now a gen folder is created. Let's take a look inside gen gen, and then there is a go directory, and then a path to our uh, package in the protobuf, which is payment/v1, if you remember that. And then inside that, there will be our generated source code from the proto file, which is payment.pb.go. Let's take a look into that. So this is the generated Go code that we will use in our service, in our server, right? If you see that the package name is payment.pb, this is basically what we define in the proto files, if you still remember that, right? So this files basically contains everything we need to interact with the schema. So I'll show you how we can use it later on, right? So yeah, that's how we generate the proto file using buff. Okay, in this section, I'm going to show you how we can use the linter. So right now I'm going to modify our proto files, right? I'll make it invalid by using the same tag number here. Save it, and then run buff space lint. Right. So now it will tell us that our proto files is invalid because our fields order ID and recipient ID both have the same tag one. So we have to fix it. So let's go fix it. Let's fix it. And then run the linter again. Right? That's it. So we can use the linter to detect any invalid proto file format. Cool. In this section, I'm going to show you how we can do formatting for our proto files using a tool called Clang-format. So basically, Clang-format able to format different languages, and one of them is Protobuf, right? So you need to install it first, right? It's very easy to install. I have already installed it in my machine, okay? Or if you use VS Code, it also has integration tools, right? To use it directly in VS Code, but you still need to install the library, which is this one, right? After you install it, you can run this command to format your code, right? The format is clang-format /I, the location of your proto files that you want to format. So let me show you the demo, right? So let's say I modify our proto files. So this is already formatted, by the way, but I will make it not formatted like this, right? To show you, just to show you, right? Maybe like this or like this, right? Cool. I will save it. Now I will run the tools called Clang-format I, and then the location of your proto files that you want to format. Run it. That's it. So let's open up again. Voila. So it's already formatted. Nice. So if you notice that in my repository I have a file called where is this? Oh, it's not showing here. Um, Let me show you in the repository. I have a file called Clang-format. So I use this uh, files basically to tweak the styles of formatting. Basically, I telling the Clang-format to format my proto files using Google styles, and then using align consecutive declaration, etc., etc. Which is you can take a look of these options in this page, right? There is a Clang-format style options. You can use this in the Clang-format files, right? Again, these links is already included in my repository, so please feel free to take a look. Okay, in this section we're going to see an example of writing some data using Protobuf that we already compiled. Okay, so the example is in example directory, and then in the writer directory there is a main.go files. So if you look at the main functions, we have order object from payment pb.order. Payment pb, basically this is the generated code from our proto files, right? So remember that we are going to use the compiled code to interact with the schema. In this case, we are going to write some data in the order object. So we write some dummy data, order ID, and then recipient ID, and then payment provider. Okay, this is our enum, right? And then after that, we use libraries from Google, right? Protobuf/proto to marshal this data that we have. Okay, so we marshal it, and then we check the error as usual. After that, if there is no error, we write the file to file name order.bin from these bytes that we already marshal using the marshaller. All right, so basically that's it. So let's try to run this. So go run writer/main.go. All right, so if you notice now, there is the output order.bin, right? So this is a binary. So if we try to uh take a look inside, yeah, we cannot see the data. But if you want to see the data, we can by using the protoc dash dash decode underscore raw, and then I guess we specify the order bin. That's it. So we use protoc decode raw, and then stream the output of the order bin, and then this is the output 1 2 3 1 2 2. So it means that this order bin has data which is 1 2 3 is the unique numbers that we tag in the fields. 1 is order ID, 2 is the recipient ID, and 3 is the payment provider, which is the value is 2. This is our enum, which is 2 is our OFO, right? If I'm not mistaken. So yeah, that's the example of writing data into Protobuf. So in the next section, we are going to see an example how we can read data from the Protobuf. In this section, we are going to see an example of reading data from the binaries that using Protobuf as a serialization technique. So the example is located at example/reader/read, I mean, and then main.go. No, reader. Yes, correct. This is the code. It's very simple and straightforward. So we specify the file name that we want to read, which is order bin that we have generated in the previous sections. And then we use os.read files. All right. And then after that, we use Proto from the library .unmarshal to unmarshal or to deserialize, right? Deserialize the data from these bytes into this data structures order, which is payment pb.order from the proto files that we have generated. And after that, we print the informations for debugging purposes. So we called order.getOrderID. So inside the generated codes, proto codes, they also provide us a getter function, so we should use it. So order.getOrderID, and then order.getRecipient ID, and then order.getPayment provider. And because this is enum, so we can access also the string representative of the enum if we want, right? So let's run this example. Go run reader main.go. Okay, the order ID 1, recipient ID is 2, and payment provider is enum. And then this is the string representation, payment provider OVO. Right, that's the example of reading data from Protobuf using Go. Okay guys, in this section, I'm going to share with you alternative for protocol buffers. If you're looking for alternatives, probably the most famous one are XML or JSON, but they have different mechanics. Another projects that I think have similar mechanics with protobufs are first Apache Thrift. It is created first time by Facebook. The Apache Thrift software framework for scalable cross-language service development combines a software stack with a code generation engine to build services that work efficiently and seamlessly between these languages. Yeah. And another alternatives is Facebook Thrift. So this is Thrift, but Facebook create their own branch. This is an involved internal branch of Thrift that Facebook released to open source community in 2014, right? So yeah, it's basically has the same things with Protobuf, a code generator, a serialization framework, an RPC framework, which is Protobuf will use gRPC for this. And another interesting project is Cap and Proto. Cap and Proto is an insanely fast data interchange format and capability based RPC systems. Think JSON except binary, so it's pretty much the same. If I'm not mistaken, the person who contribute to Cap and Proto is basically the same one that contribute to Proto version 2. And it's infinite times faster than protocol buffers because in Cap and Proto there is no encoding or decoding step. So the Cap and Proto encoding is appropriate both as data interchange format and in memory representations. So this is an interesting project. So I never used this before. So if you're curious, please visit their websites. The next one is flat buffers. This is also created by Google. Similar with protocol buffers, but I think this is has specific use case, which is for gaming, right? The next things is Microsoft Bond. This is an open source cross-platform framework for working with schematized data. It supports cross-language serialization and deserialization and powerful generics mechanisms for efficiently manipulating data. So basically, uh, if I read just from the summary, more likely it's similar. Yeah, similar concept with protobufs. So I never use these alternatives yet, so I cannot tell you more, right? But yeah, there are alternatives there, so feel free to learn and use it if you want, right? Okay, in this section is the summary sections. Basically, I'm going to share with you about when not to use and when to use protobuf. I'm not going to talk about performance because again, I never write any protobuf services before. Other team in my previous company did this and they consider using protobufs. Let's jump into this section for now when to consider protobufs. Is because they have a high throughput of requests and they need a serialization technique that has a better efficiency in terms of data so that the request can be sent faster, and also they need a strict schema, which is in JSON we cannot have, right? It's schemas, right? But in terms of performance, yes, they have better performance. But let's look into when not to use protobuf, right? When not to use protobuf, in my opinion, is premature premature optimization. Premature optimization means that maybe you are in a young startup, a young company, and then you create your services. Maybe you want to try a much more simplest way to serialize your data, which is using JSON. It's much faster, it's much easier to maintain compared to Protobuf, right? Because in early stage of companies should make things done fast as possible, right? So at that time, I think consider to use another serialization techniques if possible. And the second one is when your clients are browsers, if you have service and then you talk directly with browsers, JSON is the best serializations, right? Because browser is an excellent client of JSONs. And the last one is if you have large data sets. So it's mentioned here in the protocol buffer documentations, large data set sections. It stated that protocol buffers are not designed to handle large messages. As a general rule of thumb, if you're dealing with messages larger than 1 megabyte each, it may be time to consider an alternate strategy. Right? An alternate strategy here, I think, it's more referring to, hey, you sending too much data. Maybe you should re-architect your infrastructure so you can send more smallest data instead of one big size of data. But that's my thought, right? Again, I never write any service using Protobuf. Yeah, that's it. My learning note for Protobuf. I hope you enjoy it and then you learn something new. Thank you for watching, and I hope I can see you again in my next learning video. Until then, bye bye.